Hi folks, Dr. P here. This is Math 20-2 Statistics, Topic 2, Example 1 on page 9 in your workbook. So in this example here, we have the heights of boys participating in a basketball tournament are normally distributed about a mean of 180 centimeters and a standard deviation of 5 centimeters. In A, they're asking us to label the normal curve with the mean and the values for plus minus 3 standard deviations from the mean. So I have pasted in this little figure here, which you have in your workbook on one of the previous pages. I believe it's right on the previous page, on page 17. So this is from page 17 in your workbook. And when it's asking you to label the normal curve with the mean and the values for plus minus 3 standard deviations, it's asking you to indicate where the mean is located. So the mean is located in a normal distribution. The mean is always located right in the middle, right there. So this line right in the middle of this bell-shaped curve represents the mean. So we can label this with the mean, and we're going to use the Greek letter mu, and the mean in this particular case is 180 centimeters. And then they want us to also add the values for plus minus 3 standard deviations from the mean. So if the mean is right there, then plus 1 standard deviation is there, plus 2 standard deviations is there, and plus 3 standard deviations are over there. So when we're adding 1, 2, or 3 standard deviations, we're going to the right past the mean. When we are subtracting 1, 2, or 3 standard deviations, we're going to the left. So this will be the mean minus 1 standard deviation, be the mean minus 2 standard deviations, and this will be the mean minus 3 standard deviations. Okay. So what we want to do here is, so I'm going to be writing a little bit above here as well. It's not everything's going to fit below. So this line here represents the mean plus 1 standard deviation. So mean plus 1 standard deviation. So this is that Greek letter mu representing mean. This is the Greek letter sigma, which represents a standard deviation. So we can plug in. We want to find out what number this actually is. So we know that the mean is 180 plus 1 times the standard deviation, which is 3. No, sorry, it's 5. My bad. I was looking over here. The one standard deviation, this here is our sigma, our standard deviation. It's going to be times 5. Okay, so 180 plus 1 times 5 is 185. So now we can label it down here. So this point right here is plus 1 standard deviation above the mean, and it's represented by 185 centimeters. Now we're going to 2 standard deviations above the mean. So that's going to be mu plus 2 times the standard deviation. Plug in what we have. We have 180 centimeters. That's our mean, plus 2 times 5. 2 times 5 is 10. 180 plus 10 is 190. This is going to be 190 centimeters. And then finally, we have 3 standard deviations above the mean. So it's going to be mu plus 3 standard deviations. It's going to be 180 plus 3 times 5. 3 times 5 is 15. 180 plus 15 is 195 centimeters. Should have units here. So we write 195 centimeters. So now we have gone up 1, 2, and 3 standard deviations. Now we're going to go below the mean. So this point right here, that line represents 1 standard deviation below the mean. So the mean minus 1 standard deviation. So it's going to be 180 minus 1 times 5, 175. This is going to be 2 standard deviations below the mean. It's going to be 180 minus 2 times 5. That's 170. And then finally, we have 3 standard deviations below the mean, which is 180 minus 3 times 5, which is 165 centimeters. Okay, so we've labeled the normal curve. Now, if we take a look at this this curve here, we can see that those various regions under the normal curve are represented by a percentage. These percentages tell us what proportion or what percentage of the data would fall in these different regions. And of course, if we add all of these percentages up, that should equal to 1, because all of the data, 100% of the data, will be distributed under this bell-shaped curve. So we can use this in question B when we're trying to determine between what two values located symmetrically about the mean is approximately 68% of the data. So here we're going to be using this graph over here, and we can see that 68% of the data is 34 plus 34, and it says symmetrical about the mean. So if the mean is right in the middle, right there, right? So 68% of the data is going to be located between 1 standard deviation below the mean up to 1 standard deviation above the mean, because 34 plus 34 is 68. So we can say that plus minus 1 standard deviation, and we already know what numbers that represents, so it's going to be between 175, so between 175 centimeters and 185 centimeters, because 34% of the data is 1 standard deviation below the mean, plus 34% of the data is 1 standard deviation above the mean. 34 plus 34 is 68. Right. Let's look at the next example here. Next question. So now we're asking between what two values is 95% of the data. Again, we're looking symmetrically about the mean. So for 95%, we look at our graph up here. We take 13.5 plus 34 plus 34 plus 13.5. That's going to be 95. So we can say that it's going to be plus minus 2 standard deviation above the mean, about the mean. It's going to be between, well, 2 standard deviations below the mean is 170. So between 170 centimeters and 2 standard deviations above the mean was 190. Okay. And this is because, so the percentages, they add up. So 13.5% plus 34% plus 34% plus 13.5% equals to 95%. And then in the next question here, number 3, now we want to find out between what two values 99% of the data is located. Okay, so if we look at the graph up here again, so 99%, now we're going to go to plus minus 3 standard deviations. It's going to be plus minus 3 standard deviations. So between, so 3 standard deviations below the mean was 165 centimeters. And 3 standard deviations above the mean, it was 195 centimeters. And if we add up the percentages from 3 standard deviations below the mean, so we're looking at this, we're basically adding up all of these percentages here. It will add up to 99%. So we're going to be adding up 2.35% plus 13.5% plus 34%. So that this is on the left hand side of the mean, below the mean. We go above the mean, add up the percentages. If we add up all those percentages, we're going to get 99. So 99% of the data is between 165 and 195 centimeters. That's a wrap. Until next time, stay safe, stay healthy, and may the math be with you. See you.